Okay, so we're doing the eighth two-dimensional practice problem, which is an angle launch. Again, a reminder that if you have not done these, you want to do them yourself before you go through the video examples. If you're having trouble setting up the problems, you're getting stuck with where to put the values, please give me an email, send me an email, and we'll get you situated. Let's go through the problem. A rocket is fired at a speed of 75 meters per second from ground level at an angle of 60 degrees above the horizontal. The rocket is fired towards an 11-meter high wall, which is located 27 meters away. And it asks you, by how much does the rocket clear the top of the wall? All right, let's get an idea of what our picture looks like here. So, here's the ground level. Here is my rocket. Let's make it actually touch the ground. There we go. It's launched with an initial velocity equal to 75 meters per second. It is at an angle of 60 degrees with the horizontal. And someplace over here we have a wall. By the way, it does not matter whether you draw the wall like this, or like this, or like this. You just need to be consistent about where you measure the base. So from here to here, I'm going to say is 27 meters. We're assuming the wall is going to be nice and thin, so we don't really have to worry about how, the depth of this. We just kind of need to see where at this point it's clearing the wall, where at the front of this point it's clearing the wall. And it doesn't matter what diagram you use. Again, you just want to, or whether you measure to the middle or to the far side, you just want to make sure you're consistent in those measurements. All right, so here we go. Here's the parabola that it takes, and hopefully we are clearing the wall. From my diagram, it's a little bit skewed, but we're hoping that we're clearing the wall, and what we're actually looking for is this height here, this value. That's truly what we're going to look for. But in order to do that, we need to find the y displacement at this point. So I'm going to put a question mark in here. Please note, actually I'm going to make it a different color so you're clear that that is not the y displacement on that side, that is the difference between the y displacement, which is here, and the wall. And the wall is 11 meters high. Let's put that in our diagram so we have everything nice and visual for us. All right, let's look at that initial velocity vector. Here it is, 75 meters per second. At 60 degrees, so we have an x and a y component. And so V naught x is going to be 75 cosine of 60, and V naught y is going to be 75 sine of 60. Okay, so now we're ready to go ahead and start filling in our table. So V naught x is 75 cosine of 60, and V naught y is 75 sine of 60. And we know that there's no acceleration in the x direction, so that means the initial and final velocities in the x direction are the same. And we know that our horizontal displacement is 27 meters, that's given. And then on this side, we need to find our s displacement. We know that we have an acceleration of negative 9.8 meters per second squared. And that's really all that's sort of stated explicitly or implied in this problem. So I need to take a look in the y direction. That's where I want to find something, right? I want to find my y displacement. But I only have 2 out of the 5 values. So that means that I do indeed need time, and I do have enough information in the x direction in order to find that. And we know that these are equal. And once I find that time, then I can use the no VF formula in order to solve my problem. There's only one formula in the x direction. So let's start here. We're looking for time in the x direction, so time is x divided by v naught x. So the time is equal to 27 divided by 75 cosine 60. Now when you're typing this into the calculator, please be really careful that you hit 27 and then open parentheses 75 times cosine 60. Make sure you close your parentheses or hit enter at the end. But if you aren't careful about putting that bottom number in parentheses, you will get an error because it'll only divide by the first number. Okay, so you should get 0.72 seconds. And I was having problems in another video where my S looked like a 5, so I'm going to put this here to keep myself on track that I don't accidentally miscopy my number. And that is another strategy to help you. Alright, so now I can plug into this formula. I can't cancel anything nice and easily like I had before because V naught is not 0, so we just plug in. So V naught is 75 times the sine of 60. We're going to multiply that by 0.72, and then we're going to add 1/2 negative 9.8, and then 0.72, and make sure that you square this. So we're repeating this video because in the first one I dropped it off, the square, and that's a very common mistake. So make sure that you check that not only do you have it here, but that when you put it in the system that you actually are squaring. So let's go ahead and put that in the calculator. So I go 75 times the sine of 60. I close my parentheses and multiply by 0.72, and then I add 0.5 times minus 9.8 times 0.72, and make sure you hit that squared button next to the 2 button so that you square that last term. And so I get a y displacement of plus 44.2252 meters. Again, my final answer for y displacement would be 44.22, but careful, that's not what they asked. They asked, how much does the rocket clear the top of the wall? So for clearance, I have to take my y displacement minus the height of the wall. And so let's do that now. So I have 44.22, and I'm going to go ahead and drop, I'm sorry, 44.23. I'm going to go ahead and round that at this point. So I get 33.23 meters. And that's a scalar quantity. It's not a vector quantity, so it's not going to have any sign. And I'm going to write it up here on the top because the bottom of my paper chopped off. So the answer is 33.23 meters. That's the clearance for the